Right now, flying at about 30,000 feet somewhere over the Nevada desert, there is a matte black, jet-powered fighter aircraft.
Slicing through the air at what, near supersonic speeds?
Yeah, exactly, near supersonic speeds. And it's pulling these tactical maneuvers that would make a seasoned pilot completely black out.
Right.
It's communicating with a network of sensors, it's scanning the horizon for threats, and calculating intercept trajectories. But if you were to somehow pull alongside this jet and peer inside the canopy, well, you wouldn't see a pilot.
You wouldn't even see a cockpit, actually.
Right. The entire space where a human being usually sits, I mean, the ejection seat, the oxygen systems, the heavy glass, it's all just gone.
Completely gone. Replaced entirely by microprocessors, fuel, and payload.
And that single missing cockpit,
Yeah.
it represents something massive.
It represents the absolute dismantling of a military doctrine that has dominated the globe for the better part of a century. I mean, we are watching the real-time death of the exquisite platform.
Welcome to today's deep dive. Our mission for you today is to pull back the curtain on this profound generational shift in modern warfare.
A shift that is happening all around us right now in May of 2026.
Exactly. We've gathered a massive stack of the latest geopolitical, aerospace, and defense reports, and we're going to distill them down to give you the complete picture. Because this isn't just about, moving money around in a Pentagon budget.
No, not at all. This is a fundamental rewriting of global security.
So to really grasp the magnitude of what we are looking at in these reports, we have to look at the active laboratories of modern conflict.
Right, because we are currently seeing a convergence of protracted wars across the globe. You have the highly volatile, multi-domain conflict in the Middle East involving the United States, Israel, and Iran.
You have the grueling, entrenched war of attrition in Ukraine.
And of course, you have the devastating, high-tempo civil war in Sudan between the Sudanese armed forces and the Rapid Support Forces.
And I want to be super clear here for everyone listening. We are looking at these reports completely impartially.
Absolutely.
Our goal today isn't to take political sides on any of these conflicts. We're just here to report on the sheer undeniable operational realities they are exposing.
Because despite being geographically, politically, and culturally distinct, these three theaters are all proving the exact same thing.
Which is that traditional military calculus is just broken.
It really is. The era of relying exclusively on hyper-advanced, multi-billion-dollar military platforms, what the Pentagon explicitly calls exquisite systems, is over.
It's totally over. And why? Because they are fundamentally vulnerable to saturation attacks by incredibly cheap autonomous drones.
Right.
Okay, let's unpack this for a second. Because if you're a global superpower, you've spent the last 50 years perfecting the ultimate flying machines.
You have an entire defense industry geared entirely toward building these perfect, untouchable assets.
Yeah. So how do you wake up one morning and realize your trillion-dollar doctrine of air superiority is suddenly like a massive liability?
Well, it comes down to a very specific, undeniable mathematical trap. It's known as cost exchange asymmetry.
Cost exchange asymmetry.
Yeah, and to understand that, we really need to introduce the concept of attritable mass.
Okay, lay that out for us.
So for decades, defense strategy was based on building a small number of incredibly complex, highly expensive, low-density assets. I mean, think of a state-of-the-art guided missile destroyer or a next-generation stealth bomber.
You build the thickest armor, the most advanced radar, the fastest engines.
Exactly. The assumption was always that quality beats quantity. But attritable mass flips that entirely on its head.
How so?
It refers to the deployment of vast numbers of low-cost, uncrewed systems. The defining characteristic is that word attritable, meaning these systems are built with the explicit expectation that they will be destroyed.
That are meant to die.
Right. Their entire purpose is to be lost in combat, serving to overwhelm and exhaust those exquisite, highly expensive defense networks.
See, if I'm listening to this, my immediate thought is, wait a minute, we have radar systems that can track a golf ball from hundreds of miles away.
We have the most advanced sensors on the planet.
Right, so why on earth are these billion-dollar air defense networks suddenly blind to a bunch of commercial drones?
And that is the core engineering paradox we are dealing with here. The exquisite air defense systems, like the Patriot missile batteries or the Aegis combat systems on naval destroyers, they were designed during the Cold War.
Okay.
And they were modernized to counter a very specific type of threat. They are engineered to look for large, fast-moving ballistic signatures at high altitudes.
Like Russian fighter jets or incoming ICBMs.
Precisely. The radar arrays emit these massive pulses of electromagnetic energy, and they look for the reflection. The radar cross-section, or RCS, bouncing back from those large metal objects.
So they're looking for something moving at like Mach 2 with the footprint of a school bus.
Exactly. But a Group 1 or Group 2 drone, which often weigh less than 50 pounds and are literally derived from commercial hobbyist technology, they operate completely differently.
They fly incredibly low to the ground, right?
Very low, often using the curvature of the Earth and the terrain to hide. Plus, they're made of plastics, carbon fiber, and foam.
Which I'm guessing doesn't reflect radar the same way.
Not at all. They don't reflect radar waves the way a solid titanium jet engine does. And furthermore, radar systems have built-in software filters designed to ignore clutter.
Clutter. Like what? Weather.
Weather, sure, but also birds. I mean, if a radar system alerted the operator every time a flock of geese flew by, the system would be completely unusable.
Oh, wow.
So the software is programmed to basically ignore slow-moving, low-altitude objects with small cross-sections.
It means the multi-billion-dollar radar actively chooses to ignore the lethal drone because it thinks it's a bird.
In many cases, yes. It filters it out.
Yeah.
And when the defense network finally does detect the drone swarm, which is usually when they are terrifyingly close, the military is forced into that cost exchange asymmetry I mentioned earlier.
Right, because what do they shoot it down with?
Exactly. The only kinetic weapon the exquisite platform has to defend itself is its stockpile of highly advanced, precision-guided interceptor missiles.
And those aren't cheap.
Not at all. These missiles are engineering marvels, and they cost anywhere from $1 to $4 million apiece.
Wow. I mean, I think about it like bringing a custom-built, multi-million-dollar Ferrari to a demolition derby.
A demolition derby against 1,000 remote-controlled cars strapped with explosives?
Yeah, sure, the Ferrari is faster, the engineering is flawless, the paint job is perfect, but it doesn't matter.
No, because the Ferrari only has so much gas, and eventually one of those chip little RC cars is going to get underneath the chassis and detonate.
And even if the Ferrari magically avoids being hit, the driver basically goes bankrupt, replacing the tires and fuel while the RC operators spend pennies.
The reports highlight the sheer absurdity of this. You are firing a $3 million missile to destroy a drone built from off-the-shelf commercial parts that cost, what, maybe $2,000?
It's insane math.
It is. If you shoot down a swarm of 100 drones, your tactical defense rate is 100%. You protected the target, but strategically.
You just spent $300 million to counter $200,000 worth of equipment.
Exactly. The adversary doesn't even need to hit their target to degrade your military capability. They just need to force you to empty your missile magazines.
Because once your magazines are empty, the exquisite platform is completely defenseless.
Sitting duck.
And, we are seeing the horrific real-world human cost of this asymmetric warfare right now. The source text on the conflict in Sudan is just absolutely staggering.
It really is a tragedy unfolding in real time.
We're looking at a civil war that has already displaced over 12 million people. But the introduction of these cheap, attritable drone systems has fundamentally transformed how that war is being fought.
The data provided by the UN Human Rights Office and our sources paints a very grim picture. Armed drones have rapidly become the leading cause of civilian casualties in Sudan.
The leading cause. Let that sink in.
Between January and April of 2026 alone, drone strikes are responsible for over 80% of all conflict-related fatalities.
80%.
We're looking at a minimum of 880 deaths in a matter of months, directly attributed to these uncrewed systems.
That completely shifts the nature of the conflict. I mean, it's not just two armies clashing on a battlefield anymore. These cheap drones allow the hostilities to stretch far beyond the traditional battlegrounds.
Right.
The reports note that drone strikes are reaching deep into the White Nile and Khartoum regions, and they maintain a high operational tempo even during the rainy season.
Which is huge, because normally during the rainy season, traditional ground movements, tanks, trucks, infantry, they would be completely bogged down in the mud.
But the drones just fly right over the weather.
This is exactly why the UN Secretary General and the African Union are raising unprecedented alarms in these reports. When destructive power becomes this cheap, this portable, and this easy to operate.
It basically bypasses all the traditional constraints of military logistics.
Completely. You don't need a heavy manufacturing base or billion-dollar financing to field an air force anymore. You just need a supply chain of commercial electronics and some explosive payloads.
And the fear outlined in the geopolitical reports is that the unchecked flow of these weaponized drones into Sudan risks transforming the entire Sahel region into a contiguous sanctuary for extremist organizations.
The barrier to entry for an air force is literally near zero now.
So the old doctrine is demonstrably obsolete. The exquisite platform is a sitting duck, and the economic math of defending it is a death spiral.
A total death spiral.
Which brings us to the massive pivot. Because we have an entire defense industrial base in the United States and allied nations that has spent half a century perfecting the Ferrari.
Right.
You don't just flip a switch and turn Lockheed Martin or Boeing into a remote-control car factory overnight. How's a modern military actually pivot an aircraft carrier's worth of institutional momentum to face this new reality?
Well, if we connect this to the bigger picture, we see that the strategic pivot is much more sophisticated than simply throwing away the legacy jets and buying millions of quadcopters.
Okay, so what are they doing?
Militaries are not abandoning their advanced technology. Rather, they are attempting to integrate the concept of attritable mass into a hybrid, tiered system of autonomous warfare.
A hybrid system.
Yes. And this is the genesis of the Collaborative Combat Aircraft, or CCA.
CCAs. Okay, this is where we get back to that cockpitless jet flying over the Nevada desert that we talked about at the start.
Exactly.
So we've established the why, the absolute necessity of avoiding the economic trap of the cost exchange asymmetry. Now we're looking at the how. And these CCAs are a completely different breed from the cheap 50-pound commercial drones we just discussed, right?
Completely different. Collaborative combat aircraft are highly advanced, semi-autonomous, jet-powered drones.
Jet-powered.
Yes. As you described earlier, they are essentially high-performance fighter aircraft that have had the human element completely removed. No life support, no displays, no physical interface.
So they're drones, but they are built like fighter jets.
Right. And they are explicitly engineered to act as loyal wingmen to a human pilot operating a separate, crewed fighter jet.
Loyal wingman. You know, it's a phrase that sounds so much like science fiction. But the sources indicate this is moving from concept to reality at a speed that is almost unheard of in military procurement.
It really is unprecedented. The U.S. Air Force has accelerated the CCA program so aggressively that they went from initial conceptualization to advanced flight testing in under 2 years.
Under 2 years. For a military jet.
Right, and the speed of development is a direct reflection of the panic caused by the vulnerability of the legacy fleet. I mean, the traditional acquisition cycle for a new fighter jet can stretch across decades.
Oh, yeah. The F-35 program famously took nearly 20 years to reach full operational capability.
Exactly. And the Pentagon knows they do not have 20 years to solve the swarm problem. As of May 2026, the reports detailed 2 primary CCA prototypes already undergoing rigorous operational evaluation.
That's happened to the Experimental Operations Unit at Nellis Air Force Base, right?
Yes.
And the sources give us the exact names. We have General Atomics prototype, the YFQ-42A, which is going by the incredibly cool call sign Dark Merlin.
Very sci-fi.
And then we have Endural's prototype, the YFQ-44A, known as Fury. So these machines are out there right now integrating their onboard flight autonomy with actual combat tactics.
They are flying as we speak.
But if I'm the human pilot in the F-35 and I have 3 of these Dark Merlins flying next to me, what exactly am I asking them to do?
To understand their function, you really have to think about risk distribution. In a traditional combat scenario, the highly advanced, crewed fighter jet has to do everything.
Right.
It has to turn on its powerful radar to find the enemy, which, by the way, instantly broadcasts its own location. It has to fly into the contested airspace, lock onto the target, and fire the weapon, all while exposing the human pilot to surface-to-air missiles.
That's terrifying.
It is. But with CCAs, the human pilot becomes a quarterback. The F-35 stays dozens, perhaps hundreds of miles back in relatively safe airspace.
Okay, so the pilot stays out of range.
Exactly. The pilot acts as the command node, directing the swarm of Dark Merlins or Furies to fly ahead as the vanguard.
They go into the meat grinder so the human doesn't have to.
That's exactly it.
Yeah.
And the tactical applications are vast. A CCA can be equipped with heavy electronic warfare pods. It flies close to the enemy air defense network and blasts the radar systems with jamming signals, completely blinding them.
Wow.
Or it acts as an advanced sensor node. It pushes far ahead of the human pilot, turns on its radar, finds the enemy, and silently feeds that targeting data back to the F-35 via encrypted data links.
So the F-35 never even has to turn its own radar on.
Right. It remains completely stealthy. Furthermore, these CCAs can act as flying magazines. The human pilot might spot a target, but instead of using the missiles on their own wings, they send a command to the Fury drone flying 50 miles ahead to launch its payload.
And the most brutal application mentioned in the reports is that they act as literal decoys.
Yes.
I mean, if the enemy manages to launch one of those $3 million interceptor missiles,
Hmm.
the human pilot can just command the CCA to intercept it or draw its fire.
Yeah.
You basically sacrifice the machine to save the pilot.
It's cold, but it's effective.
And this uncrewed vanguard concept is directly shaping the design of the next generation of human-flown aircraft, right? The sources highlight the command node being built specifically to manage this ecosystem.
You're talking about the Boeing F-47 Next Generation Air Dominance Platform, or NGAD?
Yeah, the F-47.
The F-47 is a fascinating piece of the puzzle. It is the first U.S. fighter designation beyond the F-35, and the mandate from the Air Force is incredibly aggressive. They are targeting first flight for the F-47 in 2028.
2028. That's just 2 years from now.
With operational service expected before 2029. And this platform is not being designed as a standalone dogfighter. It is being built from the ground up as a massive data processing hub.
Like a flying server room.
Essentially, yes. It's designed specifically to manage, process, and direct the immense flow of information coming from a swarm of loyal wingmen.
And that timeline, 2028 for first flight, that is putting immense pressure on allied nations.
Unbelievable pressure.
Because the reports contrast the U.S. speed with international efforts. You have the Trilateral Global Combat Air Program, or GCP, which is a joint effort between the UK, Italy, and to Japan.
Right.
And they are still targeting a 2035 operational date.
And that's if things go well.
Yeah. And then the European Future Combat Air System, or FCAS program, that's bogged down in severe bureaucratic and engineering delays, slipping all the way toward a 2040 entry date.
And the delays in Europe are deeply rooted in that legacy mindset we talked about. They are still trying to engineer the perfect, exquisite platform, arguing over work-share agreements and sovereign technology transfers.
Bureaucracy at its finest.
Exactly. By the time those platforms fly in 2040, the battle space will have completely moved on. The capability gap opening up in the 2030s is a profound strategic vulnerability.
And Japan is sweating over this, aren't they?
Oh, absolutely. Our intelligence aggregation in these reports indicates that Japanese officials are acutely aware of this gap. Because of the GCK delays, they are reportedly engaging in emergency trade talks with the U.S. to purchase additional F-35s as a stopgap measure.
Just to hold the line.
Right. And they are quietly exploring whether they can integrate into the F-47 program. They realize that if you cannot field and manage an autonomous drone swarm by the end of this decade, you simply forfeit air superiority.
Period. Okay, I'm going to put myself in the shoes of a skeptical listener here and play devil's advocate for a minute.
Please do.
We started this whole discussion by saying that billion-dollar exquisite platforms are an economic death trap. And the solution is attritable, mass-cheap stuff we can afford to lose.
Yes.
But these Dark Merlins and Furies, I mean, they are jet-powered, they carry advanced electronic warfare pods, they have cutting-edge AI processing units, they carry high-end missiles.
They're very sophisticated.
So are these CCAs truly attritable? Meaning, if one gets blown up, is the Pentagon actually shrugging it off? Or are we just building slightly cheaper pilotless fighter jets that will inevitably suffer from the exact same cost bloat, putting us right back in the same economic trap?
And that right there is the defining tension within the defense engineering community right now. It is the absolute hardest needle to thread.
Right.
Because if you make a drone smart enough to fly formation with an F-35 at Mach 1, evade advanced surface-to-air missiles, and execute complex electronic attacks, well, you have inherently stuffed it full of highly expensive sensors, processors, and materials.
Exactly. If Dark Merlin ends up costing $50 million a pop, we haven't solved the cost exchange asymmetry at all. We've just figured out a way to crash slightly cheaper Ferraris without killing the driver.
The defense industry's counterargument is that we cannot look at the CCA as a single homogeneous entity. The objective is to build an ecosystem with a sliding scale of attritability.
A sliding scale. What does that look like?
You will have some loyal wingmen that are highly sophisticated, heavily armed, and intended to return to base. You will have others that are essentially just a jet engine strapped to a basic sensor, manufactured for a fraction of the cost.
And those are fully expected to be one-way decoys.
Exactly. But the larger point, the real synthesis of this strategy, is about shifting the burden of survival.
Shifting the burden of survival. Okay, unpack that. Meaning what, exactly?
Think about the engineering of a crewed fighter jet. The sheer amount of weight, space, and money dedicated solely to keeping the human being alive is staggering.
Oh, I'm sure.
You need life support systems, oxygen generation, pressurized cabins, heavy ejection seats, reinforced canopies. Furthermore, because you cannot compromise on the pilot's life, the aircraft must be wrapped in billions of dollars of stealth coating, carry heavy armor plating, and feature quadruple redundant flight computers.
Because if the computer fails, the pilot dies.
Right. By decoupling the human from the immediate kinetic threat, by shifting that risk to a robotic vanguard, you fundamentally alter the engineering requirements. The F-47 doesn't need to carry every single sensor or weapon if it can delegate those tasks to a dozen Furies.
Oh, Oxy.
Even if a Fury costs $20 million and is destroyed, you have preserved your most valuable, irreplaceable asset. The multi-million-dollar trained pilot and the billion-dollar command node.
It's the ultimate decentralization of air power. Instead of putting all your eggs in one heavily armored, exquisite basket, you spread the eggs out into a networked swarm.
Exactly.
And what is truly wild as you read deeper into these reports is that this concept, the loyal wingman, the attritable swarm, it isn't staying contained to 30,000 feet.
No, it's everywhere.
It is bleeding into every single domain of the battle space. We've talked about fighter jets, but the swarm is rapidly expanding downwards right into the dirt.
The high-altitude fixed-wing domain was merely the proving ground. The logic of attritable mass applies equally, and perhaps with even greater urgency, to the low altitudes.
Like helicopters.
Take, for example, the U.S. Army's aggressive push into this space. They are currently soliciting proposals for their own variant of CCAs, tailored entirely for rotary wing operations.
Helicopters, the absolute workhorses of the Army. But helicopters are notoriously vulnerable, aren't they?
Extremely. They are loud, they are relatively slow, and they fly low where anyone with a shoulder-fired missile can take a shot.
And the specs the Army is asking for in these reports, I mean, they are mind-bending. They want uncrewed systems that can physically launch mid-flight from crewed helicopters.
Which is a huge aerodynamic challenge on its own.
Right. And they require these drones to operate autonomously at extremely low altitudes. We're talking approximately 30 meters or about 100 feet off the ground.
And they have to do this at high speeds to support ground maneuver forces.
I'm just trying to imagine the fluid dynamics of a drone dropping out of a Black Hawk, stabilizing in that massive rotor wash, and then sprinting ahead over the treetops.
It is a massive engineering challenge, but it is born out of absolute operational necessity. The war in Ukraine has vividly demonstrated that sending a massive crewed rotorcraft into heavily contested, drone-saturated airspace is practically a suicide mission.
Yeah, you just can't do it anymore.
Traditional attack helicopters are too valuable to risk against layered air defenses and cheap FPV kamikaze drones. The U.S. Army needs a vanguard to push ahead of the helicopters, map the terrain, identify the anti-aircraft emplacements, and clear the landing zones before the human crews arrive.
And we see this exact same panic mirrored in the UK's strategy.
Yes, the British Ministry of Defense just launched something called Project NYX.
The NYX, right. They've poured an initial £10 million investment into funding 4 defense firms, including heavyweights like Anduril and BAE Systems.
And the mandate there is to build autonomous, attritable wingmen specifically for the British Apache attack helicopter fleet by the year 2030.
And again, the economic math is impossible to ignore. An Augusta-Westland Apache AH-64E costs roughly £46 million.
Exactly. You simply cannot risk a £46 million asset, let alone the highly trained pilots inside, to go hunting for a $2,000 explosive drone.
They need the autonomous wingmen to form a defensive screen around the Apaches.
Exactly. The helicopter becomes the airborne command post, managing the swarm that does the actual fighting. But defensive screens are only half of the equation.
Was the other half.
As the autonomy of these systems matures, the swarm technologies are becoming devastating offensive tools. We are looking at the development of systems designed to penetrate deeply into enemy territory without any human oversight whatsoever.
Here's where it gets really interesting and, honestly, a little terrifying.
It is terrifying.
The reports detail a highly classified program from DARPA, the Pentagon's Defense Advanced Research Projects Agency, And they are developing what they call containerized drone swarms.
The containerized swarm concept is a profound paradigm shift in logistics and force projection.
I had to read this section of the report 3 times because it reads exactly like a techno thriller.
It really does.
DARPA is designing systems that can rapidly deploy hundreds of autonomous, networked munitions from what look like standard, disguised, intermodal shipping containers.
Just a normal shipping box.
Imagine a standard 20-foot metal shipping container. It looks like it's full of auto parts or electronics or grain. It gets positioned deep behind enemy lines. Maybe it's dropped off by a commercial semi-truck or left sitting in a bustling commercial port or loaded onto an unassuming cargo train.
It just sits there silently.
And then, upon receiving a coded command, the roof of the container violently retracts and a swarm of hundreds of interconnected, AI-driven weapons launches into the sky simultaneously.
It is quite literally a digital Trojan horse.
Once that box opens, it is a localized apocalypse for whatever military base, fuel depot, or command center it was parked next to.
What's fascinating here is how the containerized swarm completely obliterates a traditional military concept of front lines.
Right, because the lines don't exist anymore.
Historically, military strategy relied on geographic depth. You have the messy, kinetic fighting at the front line, but miles behind that front, you have a safe rear echelon.
You have secure supply dumps, sprawling logistics hubs, mechanics fixing tanks, generals in command tents.
Exactly. The assumption was that distance equaled safety. But if a stealth swarm can be deployed from an unassuming metal box placed anywhere in your territory by a commercial truck, the rear echelon vanishes.
The logistics depot 50 miles behind the border is now just as vulnerable as the frontline trench.
There is no behind the lines anymore. Everywhere is the front line.
How do these things even coordinate? I mean, if they are deep behind enemy lines, they probably don't have GPS, right?
That is the key technological hurdle DARPA is solving through mesh networking and edge computing. In a heavily contested environment, GPS will absolutely be jammed or spoofed.
Okay.
Satellite communications will be denied. Therefore, the container swarm cannot rely on a human operator remotely flying them with a joystick. Once launched, the drones establish a local encrypted mesh network among themselves.
A local network, just between the drones.
Exactly. They use visual odometry, which means cameras matching the terrain below to preloaded digital maps to navigate.
So they literally look at the ground to know where they are.
Right. And they share targeting data instantaneously across the swarm. If one drone spots an air defense radar, it instantly alerts the other 99 drones.
They talk to each other.
They autonomously decide which drone is in the best position to dive on the target, while the rest of the swarm reorganizes its flight path to maintain maximum coverage.
It's a hive mind operating at computer speeds.
It is.
And it's not just the United States developing this offensive capability. The reports highlight significant advancements from India's Aeronautical Development Establishment, or the ADE.
Right.
They're pushing forward with a high-speed, stealthy swarm drone derived from their SWIFT program. That stands for Stealth Wing Flying Testbed.
India's SWIFT program is highly indicative of the global proliferation of this technology. These are attritable, uncrewed aerial vehicles featuring a meticulously engineered low-radar cross-section.
Okay, what does that mean in practical terms? How do you make a swarm drone stealthy?
Well, it's about geometry and materials. Traditional aircraft have lots of right angles tails, external weapons, air intakes, which act like corner reflectors, bouncing radar waves straight back to the source.
So they light up on the screen.
Exactly. The Swift drones utilize a blended wing body design, similar to a miniature B-2 bomber. The smooth, sweeping curves deflect incoming radar energy away from the receiver.
Very slick.
Combined with radar-absorbent materials in the skin, these drones are virtually invisible to traditional early warning systems. They are designed specifically to slip through the cracks of hostile air defense networks, conduct advanced intelligence, surveillance, and reconnaissance (ISR), and, when necessary, transition into kamikaze strike mode.
Stealth kamikaze swarms operating on HiveMind AI.
Yeah.
It's a lot to process.
It's a completely new paradigm.
But let's ground this for a second. It is one thing for defense analysts to talk about jet-powered CCAs fighting at 30,000 feet, or stealth swarms launching from shipping containers. It's a very abstract, strategic conversation.
Right.
But how does the actual human soldier on the ground, the 18-year-old infantryman sitting in the dirt, actually survive this?
That's the ultimate question.
If I'm on patrol and a containerized swarm opens up next to my convoy, it sounds like an unsolvable problem. We have to look at how the human element is adapting to these vertical threats, because there are live fire exercises happening right now trying to figure out if human infantry can even exist on this new battlefield.
The tactical burden currently being placed on the individual infantry soldier is unprecedented in the history of warfare. The multinational exercises documented in these reports provide incredible granular insight into how human operators are desperately attempting to cope.
Coping with an environment where lethality can arrive from any angle, at any second, with zero warning. The major exercise highlighted in the May 2026 reports is called Project Flytrap 5.0. It's taking place in the dense forests and plains of Lithuania.
Right, involving soldiers from the U.S. Army's 2nd Cavalry Regiment working alongside the UK's Parachute Regiment.
And the entire purpose of this live-fire simulation is to pit conventional infantry against these exact types of autonomous drone swarms.
Yes.
The fundamental tactical shift described by the commanders on the ground is jarring. They state explicitly that infantry must pivot their entirely philosophy of survival from managing purely horizontal threats to managing 360-degree vertical threats.
Think about the entirety of human military history up to this point. For millennia, warfare has been a profoundly horizontal endeavor.
Right.
If you built a high wall, if you dug a deep trench, or if you simply hid behind a large rock or a berm, you were generally protected from enemy fire because the threat arrows, bullets, artillery shells moved horizontally across the ground towards you.
You kept your head down and you looked forward.
Exactly. But a trench offers zero geometric protection from a quadcopter hovering 200 feet directly overhead, preparing to drop a mortar shell squarely onto your helmet.
Nowhere to hide.
The very concept of cover has to be reimagined in 3 dimensions.
Imagine the sheer psychological terror of that environment. You are a squad leader trying to advance your team on an objective. You can't just scan the tree line for sniper glint anymore.
Yeah.
You have to constantly scan the sky, straining your eyes against the glare of the sun, trying to spot a piece of gray plastic the size of a dinner plate falling at you at 100 miles an hour.
And human necks aren't built to look straight up while running with 80 pounds of gear.
They really aren't.
The reports detail how this leads to severe neurological exhaustion. The cognitive load of maintaining that level of hypervigilance degrades a soldier's decision-making ability within hours.
I can't even imagine.
And the physical adaptations the infantry are making at the ground level are a testament to human ingenuity born of absolute desperation. For example, the reports note that frontline units in Project Flytrap 5.0 are heavily relying on 3D printing for rapid field repairs.
3D printing in a muddy trench. How does that even work practically? You don't have stable power grids in a war zone.
They are using ruggedized, battery-powered resin and filament printers. Because the airspace is so saturated with enemy drones, traditional logistics are completely paralyzed.
You can't get supplies in.
You cannot safely drive a supply truck down a road to deliver a replacement part for a broken rifle or a damaged radio antenna. The truck will be targeted immediately.
So they just make it themselves.
So the units download encrypted CAD files via satellite link, power the printer off a portable solar generator or a vehicle battery, and print the polymer replacement parts right there in the dirt.
That is wild.
They're even printing aerodynamic casings and customized payload drops for their own drones.
Right, because the infantry squad isn't just taking fire. They are fighting fire with fire.
Right.
The reports mention they're deploying their own first-person view, or FPV, attack drones.
Exactly.
Every infantry platoon now has to operate its own micro-air force just to counter the enemy's micro-air force. But to me, the most primal, chilling adaptation observed in Project Flytrap 5.0 isn't technological. It's biological. It's auditory.
Relying on sound.
Soldiers are actively, rigorously training to identify the specific acoustic signatures of incoming one-way attack munitions.
Yes. The physics of drone propulsion creates very distinct sound profiles. A quadcopter uses small, high RPM electric motors. The rotors slicing through the air generate high-frequency acoustic waves.
Like a high-pitched whine.
Soldiers are learning to differentiate between the deeper hum of a friendly surveillance drone and the high-pitched aggressive whine of an enemy FPV drone in a terminal dive.
That detail gave me absolute chills. Relying on sound to survive, it harkens back so vividly to World War II during the Blitz.
Doodlebugs.
Yes. The people of London learned to listen for the specific pulsing buzz of the German V-1 flying bombs. As long as you heard the buzzing, you were okay. If the buzzing stopped, you knew the pulse jet engine had cut out and a ton of high explosives was falling from the sky.
It's a perfect analogy.
But we're talking about 2026. With modern electric motors, these drones are hyper-fast. By the time the acoustic wave reaches your ear and your brain processes the specific pitch of the whine, how much time do you actually have to react?
In a best-case scenario, perhaps 3 to 5 seconds, often less than 2.
Less than 2 seconds.
It requires muscle memory to instantly dive for cover before the conscious mind even fully registers the threat. You are asking human beings to fight an enemy that does not sleep, does not feel fear, and can swarm in numbers that fundamentally overwhelm human cognitive processing.
Which brings us to the ultimate friction point here. If I'm a soldier in that platoon, I physically cannot look up 247, and I cannot shoot down a swarm of 100 incoming kamikaze drones with my standard-issue M4 rifle. The math simply doesn't work.
It does.
And we've already established that hauling around $1 million Patriot missile launcher to protect a 12-man squad is economically impossible. So how does a platoon actually fight back against a swarm?
That leads us directly into the technological countermeasure that defense contractors are frantically rushing from the lab to the front lines.
It's a new shield.
If you cannot shoot them all down physically with kinetic interceptors, with bullets and missiles, you have to shift domains. You have to take them down electronically. You must find a way to sever the invisible nervous system that controls the swarm.
So we are moving from bullets to bytes. We're talking about localized electronic warfare, or EW.
Right.
The reports detail a massive, multi-billion-dollar shift toward this domain. For example, there's the Pentagon's Joint Interagency Task Force, 401, JIATF 401. They've recently initiated a pilot program deploying directed energy systems.
Which means high-energy lasers and high-power microwaves to protect critical domestic infrastructure from drone threats.
Lasers.
But directed energy is excellent for static defense. If you need to protect a nuclear power plant or a major naval port, you can install a massive laser system.
But you can't walk around with one.
Exactly.
Right.
Directed energy weapons require massive power generation and heavy cooling systems. You cannot miniaturize a weapons-grade laser and hand it to a 19-year-old infantryman to carry through a swamp.
Not yet, anyway.
For the maneuver forces on the ground, the solution must be lightweight, portable, and elegant.
And that elegant solution dominates the latter half of these reports.
Yeah.
It's a program called Wraith Shield.
Wraith Shield is perhaps the single most critical tactical innovation discussed in these documents. It is a software upgrade developed by the defense contractor L3 Harris.
Okay.
And what makes Wraith Shield so revolutionary is its form factor. It does not require the infantry to carry a single new, heavy piece of hardware into battle. Instead, it utilizes equipment they already have.
So they don't have to carry anything extra.
Right. It transforms standard Falcon IV tactical radios, the exact gear that squad leaders and radio men are already carrying strapped to their chest rigs for vocal communication, into a distributed, highly lethal electronic warfare network.
That is incredible. A software solution to a hardware problem. You take a walkie-talkie, you push a digital update to it, and suddenly it's an anti-aircraft weapon.
That's essentially it.
But how does that actually work in the field? How does a radio physically stop a drone?
To understand Wraith Shield, we have to look at the physics of software-defined radios, or SDRs. Traditional radios are built with physical circuits tuned to specific frequencies.
Like tuning into an FM station.
Right. A software-defined radio replaces those physical circuits with computer processors. It can listen to and broadcast on almost any frequency across the spectrum just by changing the code.
Wow, okay.
When a platoon networks their upgraded Falcon IV radios together, they establish what is essentially an invisible, localized electromagnetic bubble around their patrol.
Like a localized force field.
Exactly. These networked radios continuously, passively scan the surrounding radio frequency spectrum. They are listening for the specific encrypted control links or video telemetry feeds used by hostile FPV drones, usually operating in the 2.4 or 5.8 gigahertz bands.
Just waiting to hear them.
Because there are multiple radios in the platoon, they use triangulation to pinpoint the exact direction and distance of the incoming drone. Once the threat is classified, the radios instantaneously shift from passive listening to active emission.
And then what?
They blast targeted, high-powered jamming signals on that exact frequency.
So the enemy drone operator is sitting miles away, looking at a video feed on his tablet, flying the drone toward the platoon. The drone hits the invisible boundary of the Wraith Shield bubble, the radio signal is overwhelmed by the jamming noise, and the video feed instantly goes to static.
Yes.
What happens to the drone physically?
Without a control link, a commercial-derived FPV drone cannot fly. Depending on its programming, it will either instantly drop out of the sky like a rock, or its fail-safes will trigger, causing it to go into an automatic stationary hover.
Oh, that's perfect.
At that point, it ceases to be a hypersonic threat and becomes a static target that an infantryman can easily shoot down with a rifle.
It is a brilliant pivot.
Okay.
You are countering a cheap, mass-produced physical threat with an invisible, software-defined, decentralized electromagnetic dome.
It's the only way to level the playing field.
But the reports provide a fascinating counterintuitive twist here. We spent this entire deep dive talking about uncrewed systems, autonomous AI swarms, and software-defined force fields. You would think the human being is being entirely engineered out of the loop,
You would think so.
but the military is realizing that in the midst of all this robotic chaos, human oversight in the sky is more vital than ever.
Yes. The relentless drive toward autonomy has ironically highlighted the irreplaceable value of human cognitive flexibility. Algorithms are rigid. Humans are adaptable, and we see this dynamic play out clearly in the Pentagon's recent, highly publicized procurement reversal regarding the Boeing E-7 Wedgetail.
The Wedgetail. For those unfamiliar, this is a crewed airborne early warning and control aircraft, an AEW&C.
Yes.
If you've ever seen a picture of a military Boeing 737 with a massive surfboard-shaped radar dome strapped to the top of the fuselage, that's what we're talking about. They're essentially flying air traffic control towers.
Correct. For years, the prevailing assumption within the Pentagon was that forthcoming space-based surveillance architectures, vast networks of advanced low Earth orbit satellites would render these vulnerable, human-crewed radar planes obsolete.
Because satellites can see everything.
Satellites can see everything, and you can't shoot them down easily. Based on that logic, the Pentagon had actually planned to cancel the procurement of the E-7 Wedgetail.
But the reality of the multi-domain war in the Persian Gulf forcefully changed their minds.
Absolutely. The intense, highly contested air campaigns over the Gulf demonstrated the severe limitations of space-based assets. Satellites operate in fixed orbits.
And there's latency, right?
Massive latency issues. It takes time for a signal to go from space down to a ground station in the U.S. and back out to a fighter jet in the Middle East. That latency might only be a few seconds, but in modern warfare, seconds are lifetimes.
Everything is moving too fast.
When you have an airspace absolutely saturated with friendly, loyal wingmen, enemy kamikaze drones, incoming ballistic missiles, and crewed fighter jets all operating in the same 30-mile radius, the latency of a satellite network simply cannot keep up.
It just can't process it.
You need a human crew physically present in the theater, sitting at radar consoles in the sky, managing the chaos, and providing rapid airspace deconfliction in real time.
You need a human being to look at the radar screen and instantly realize, hey, that friendly swarm of dark Merlins is about to collide with our own incoming cruise missile, and manually divert them.
Exactly. An AI might hesitate or require a rigid protocol, but the human brain intuitively grasps the spatial geometry and acts instantly.
And so, recognizing this, Secretary of Defense Pete Hegseth signaled that they are officially restoring full funding for the E-7 Wedgetail in the fiscal year 2027 budget.
Full funding restored.
And just to put the sheer scale of this entire pivot into perspective, that budget request is a historic $1.5 trillion. And hidden within that staggering number is an 800% increase in artificial intelligence investment.
An 800% increase. It's staggering.
So what does this all mean? We've gone on this incredible, sweeping journey through the reality of modern warfare today. We started with the jarring realization that multi-billion-dollar exquisite legacy platforms, the Ferraris of the sky, are essentially sitting ducks against cheap tech.
Yes.
We explored the mathematical nightmare of the cost exchange asymmetry. We looked at how militaries are pivoting to attritable mass, developing collaborative combat aircraft like the Dark Merlin to act as robotic vanguards and risk sponges for human pilots.
Right.
We saw the terrifying evolution of offensive swarms launching autonomously from deceptive shipping containers. And we grounded it all in the mud with the infantry, looking at how soldiers are using 3D printers and software-updated radios to create invisible wraith shield bubbles just to survive the vertical threat.
And through it all, we realized we still desperately need human beings in flying radar planes to orchestrate the madness.
Exactly. So what is the big takeaway here?
It means that the fundamental architecture of military power has been permanently altered. The rigid, top-down hierarchies of traditional warfare, built entirely around a few exquisite assets, are collapsing.
They just don't work anymore.
They are giving way to networked, highly adaptable, and largely disposable systems. A doctrine of tomorrow is defined by attritable mass, edge computing, and software-defined electronic warfare.
And we want to remind you, the listener, why this matters so deeply to your everyday life. This isn't science fiction. We are not analyzing a script for a summer blockbuster.
No, this is real life.
The rules of global security, conflict resolution, and military power are being rewritten in real time right now in May 2026. The conflicts acting as the live fire catalysts for this shift in the Middle East, in Ukraine, and in Sudan are not isolated events.
They have rippling effects everywhere.
They're actively disrupting the global supply chains you rely on. They're causing devastating energy crises, dictating the price of goods, and threatening global macroeconomic stability.
The autonomous technology being rapidly developed to win these wars today will inevitably spill over.
It will shape the civilian airspace of tomorrow. It will dictate the security of our domestic infrastructure, and it will redefine the balance of power on the world stage.
And as we navigate this profound transition, the most critical takeaway is that while the technology is increasingly autonomous, the act of adaptation remains deeply, inherently human.
Always comes back to the humans.
From an 18-year-old soldier figuring out how to jury-rig a 3D printer in a muddy trench, to a squad learning the specific acoustic hum of a lethal electric motor, human ingenuity remains the ultimate wildcard.
It really is.
An increasingly automated battlefield does not erase the human element, it simply tests its limits. The technology, no matter how advanced, only functions because human beings find ways to endure it, counter it, and ultimately wield it.
That is such a crucial grounding point. It always comes back to the human being at the center of the chaos. But I want to leave you with a final provocative thought to ponder, something that builds on everything we've unpacked today.
Okay.
As I was combing through the final pages of our source material, I noticed a brief section detailing how the commercial aviation industry is currently integrating something called agentic AI.
Agentic AI.
Now, unlike the simple AI algorithms we are used to, which just follow a rigid set of pre-programmed rules, agentic AI systems have true autonomy. They have the ability to execute complex, multivariable decisions in real time, completely independently, adapting to obstacle to achieve a broad goal.
True autonomy.
The commercial sector is beginning to use agentic AI to manage vast global flight networks without constant human input. So consider the trajectory we've mapped out today.
Where does this go?
As military drone swarms grow exponentially in size and complexity, as they rely more and more on AI to navigate without GPS, to instantly adapt to those invisible electromagnetic wraith shield bubbles, and to execute lethal missions at speeds human neurology simply cannot match. How close are we to the ultimate threshold?
It's a scary thought.
How close are we to a battlefield where two opposing agentic AI swarms detect each other, engage, dynamically adapt their tactics, and fight an entire devastating battle from start to finish, completely outside the bounds of human reaction time? Are we actively building the architecture to wage wars faster than we can even watch them happen?
It is a profoundly unsettling trajectory, and it is a reality we may face before the decade is out.
It really is. Thank you for joining us for this deep dive. Keep looking up, keep asking questions, and we'll see you next time.